Okay, let us continue. 好，让我们继续。Figure 4.13 illustrates the basic principle behind Doppler spread for a simple case where a transmitter is moving relative to two stationary scattering objects with a stationary receiver。那么这个图4.13呢，就描绘出呢，在这个一个简单的情形之下，都普勒扩展背后的基本原理。其中呢，一个传送端是移动的，相对于两个静止的散射体以及一个静止的接收器。OK。Figure 4.13 shows a simple illustration showing how Doppler spread occurs。那么图4.13呢，就秀出了一个简单的图，那描绘出呢这个都普勒扩展是如何发生的。OK，here is a transmitter 这里呢是一个传送器 ，and it moves toward the right，with velocity v。然后呢，这个传送端呢向右移动，速度是等于 v。And here is a stationary receiver。那么这边呢是一个静止的接收端。And this and this are two stationary scattering objects。那这个和这个呢，是两个静止的散射体。The carrier frequency of the transmitter is Fc。那么传送器的载波频率呢是 Fc。So for the direct path，所以呢，对于直接路径而言呢 ，the carrier frequency at the receiver is also Fc。在这个接收端的载波频率呢也是 Fc。And when the signal scattered by these scattering objects and arrived at receiver, the frequency become Fc plus Fd。那么当这个传送端传送讯号然后被这个散射体给散射，然后再到达接收端之后呢，频率是 Fc 加 Fd。Where Fd is the maximum Doppler shift， 那么这个 Fd 称之为最大都普勒偏移。And when the signal scattered by this scattering object and arrives at the receiver, the frequency is Fc minus Fd。那么当信号被这个散射体所散射，然后达到接收器的时候呢，频率是 Fc 减 Fd。OK，so the transmitted spectrum，所以呢，这个传送的频谱呢 is this，这是这个图。When the frequency f is equal to Fc， 当这个频率等于 Fc 的时候呢，there is an impulse， 有一个脉冲 ，and this is the received spectrum。那这个是接收到的频谱。At the frequencies Fc minus Fd、Fc and Fc plus Fd, there are three impulses。那么在频率 Fc 减 Fd、Fc 以及 F 加 Fd 这三个频率呢，各有一个脉冲总共有3个脉冲。So the BD the Doppler spread is equal to this width。好，所以呢，这个 BD 也就是都普勒扩展呢，就等于这个宽度which is equal to 2 times Fd 就等于2倍的 Fd。The simple example above was provided merely to show, in principle, how relative motion in a channel can lead to a broadening of the spectrum。那么以上我们所提供的这个简单的范例呢，只是要秀说在原理上，那么在一个通道中相对的运动呢是如何导致频谱上变宽的现象。This is obviously only one of many possible scenarios, however. 然而呢，这只是众多可能的场景的其中一个场景。Another type of geometry in which spectral broadening occurs is shown in Figure 4.14。那另外一种几何的图形在这个几何图形当中呢，这个频谱也会产生变宽的现象，我们就秀在图 4.14。Okay, Figure 4.14 shows the geometry associated with Clark's Doppler spread model。那么图 4.14 当中呢，秀出了克拉克的都普勒扩展模型的几何图形。Okay, here is the transmitter。好，这里是传送端。It is stationary， 是静止不动的。And the carrier frequency is Fc。那么这个载波频率呢是 Fc。And here are 8 scattering objects A, B, C, D, E, F, G, H。那这边呢有8个散射体分别称之为 A, B, C, D, E, F, G, H。They are all stationary， 它们都是静止的。And in the center of the scattering objects, here is the receiver。那么在这8个散射体的正中央呢，有个接收器 ，and it moves toward the scattering object A with the velocity v。那么这个接收器呢是往这个散射体 A 的方向移动，速度是 v。In this figure, it is the transmitter that is fixed.And the receiver that is moving。在这张图当中呢，传送器是固定的，接收器是移动的。In addition, we assume that the receiver is surrounded by a circular ring of scatterers, and that there is no direct component between the transmitter and the receiver。此外，我们假设接收器呢被一些散射体所环绕，那么这些散射体呢排列成为一个圆形的环。那么在传送器和接收器之间呢没有直接的分量。Okay, you can see that here is the circular ring of the scatterers。你可以看到呢，这边是散射体所排列成一个圆形的环 ，and no direct component between the transmitter and the receiver。那么在传送器跟接收器之间呢，没有这个直接的路径直接的分量。This is an idealized depiction of what happens when a vehicle is driving through an urban environment and receives a signal from a cell tower after scattering from buildings and objects surrounding the receiver。那么这是一个理想上的描述，就是呢，就是当呢一个车子它行驶经过一个都会区的环境，然后从一个细胞塔接收到一个信号。那接收到的信号呢，是在经过建筑物接收器周围的建筑物还有物体散射之后所收到的信号。 Here, the cell tower means the base station. 这边的细胞塔的意思呢，就是基地台。In the geometry shown in Figure 4.14, the signal arrives at the receiver with many different frequencies. 那么在这个图 4.14 所秀出的几何图形当中呢，这个信号会以不同的频率到达接收器。Okay, here is the figure 4.14. 好，这里呢就是我们的图 4.14. For example, energy scattered from scatterers A and E arrives at the receiver with frequencies equal to Fc plus Fd and Fc minus Fd respectively. 举例来说呢，这个能量会被这个散射体 A 跟 E 所散射，然后到达接收器的频率分别是等于 Fc 加 Fd 以及 Fc 减 Fd。Okay, you can see that a scattered energy scattered by the scattered by the scatterer A and the scatterer E, and the frequency are Fc plus Fd and Fc minus Fd, respectively. 你可以看到呢，这个能量被散射体 A 跟散射体 E 所散射。那么到达接收器的频率呢，分别是 Fc 加 Fd 以及呢 Fc 减 Fd。On the other hand, energy from scatterers C and G arrives with frequency equal to Fc because the receiver is moving perpendicular to them. 那另外一方面呢，能量从散射体 C 还有 G，到达接收器的频率呢，等于 Fc。因为呢，这个接收器它的移动的方向呢，是跟 C 和 G 的方向垂直的。Okay, we can see that energy from the scatterers C and G and arrives at the receiver. Okay, and the frequency is equal to Fc. 我们可以看到呢，能量经过这个 C 和 G 的散射之后，到达接收器的频率是等于 Fc. Because the direction of the receiver, 那因为呢，这个接收器移动的方向 is perpendicular to CG line segment. 那么是垂直于呢 C 跟 G 这个线段连线的方向。For the geometry shown in Figure 4.14, Gens has analyzed the power spectral density of the received signal as a function of frequency. 那么对于在图 4.14 所秀出的几何图形呢，Gens 分析了这个接收信号的功率频谱密度，作为这个频率的一个函数。Okay, here is Figure 4.14. 这边呢就是图 4.14. In his analysis, he assumes that the arriving electromagnetic energy comes from all directions with equal amplitudes. 在他的分析里，他假设到达的电磁能量呢，是以相同的振幅来自于所有的方向。The resulting spectrum is referred to as Clark's model. 好，这个结果所产生的频谱呢，就称之为克拉克的模型。For the case of a vertical quarter wave whip antenna, Gens shows that the received spectrum, capital S of F, has the following form. 那么对于一个垂直的1/4波长的边状天线 ，OK，whip 这个字呢，意思就是鞭子的意思啊，所以是一个鞭子形状的天线。And the quarter wave means the length of the antenna is equal to 1/4 of the wavelength. 那这个 quarter wave 1/4波的意思呢，是这个天线的长度是等于波长的1/4。好，那么 Gans 证明呢，接收到的频谱大 S of f 具有以下的形式。Capital S of f is equal to 1.5 over pi times fd times the square root of 1 minus f minus fc over fd square。那这个大 S of f 呢，就等于 1.5 除以 pi fd 乘以根号1减 f 减 fc 除以 fd 的平方 ，where fd which is equal to v times fc over c is the maximum Doppler shift。其中呢 ，fd 等于 v 乘以 fc 除以 c 是最大都普勒偏移 ，and c is the speed of light。那么 c 呢，就是光速。Figure 4.15 shows 3 example plots of the Doppler spectrum based on equation 4.34 for speeds equal to 20, 40, and 60 miles per hour, assuming a carrier frequency equal to 2.4 GHz。那么图4.15就秀出了这个基于呢方程式4.34的都普勒频谱的3个范例的图形。那么速度呢，分别是等于每小时20、40还有60英里。假设载波频率等于2.4个10亿赫兹。1 mile is approximately 1.61 kilometers。那么1个英里呢，大概是等于1.61公里。Okay, let us look at figure 4.15. 好，让我们看到图4.15。Figure 4.15 shows the Clark Doppler power spectrum for an unmodulated CW carrier at 2.4 GHz。那么图4.15呢，秀出了在频率是2.4个10亿赫兹的时候，对于一个没有调变的 CW 载波的克拉克都普勒功率频谱。CW means continuous wave。那这个 CW 呢，意思是这个连续波continuous wave 的缩写。The x-axis is f minus fc in hertz。那么横轴呢是 f 减 fc， 单位是赫兹。From minus 250 hertz to 250 hertz， 从负250赫兹到250赫兹。The y-axis is the power spectral density。那么纵轴是功率频谱密度。From 0 to 0.025， 从0到0.025。Here are 3 curves。这里有3条曲线。The dashed line denotes the y being equal to 20 miles per hour。那么这个虚线呢是代表大 y 等于每小时20英里。Where the capital Y is the velocity。那其中呢，这个大 Y 代表的是速度。And the dashed dot line is for y which is equal to 40 miles per hour。那这个虚线加上点线呢，这条线呢代表的是 y 等于每小时40英里 ，and the solid line is for the y being equal to 60 miles per hour。那么这个实线的曲线呢，代表的是速度等于每小时60英里。Okay, let us look at equation 4.34。好，现在呢，让我们看到方程式4.34。Okay, is this function is this equation？ 好，就是这个方程式。The U shape of these curves is characteristic of the Doppler spectrum associated with a uniform circle of scatterers。那么这些曲线呢，我们可以看到都呈现这个 U 的形状。那这个形状呢，就是许多的散射体形成一个均匀的圆圈，所对应到的都普勒频谱的特性。Okay, in the last year， 在去年呢 ，a student asked me a question。一个学生呢问了我一个问题。Okay, let us see the handouts。好，让我们看到我们的讲义。Oh, I am sorry, I forget to tell you about what is the vertical quarter wave whip antenna。抱歉，我刚才在这个138页呢，忘了跟你讲这个问题一，什么是这个垂直1/4波边状天线 ？Solution: The vertical whip antenna is the most widely used omnidirectional antenna found in the military。好，解答。这个垂直边状天线呢，是在军事当中最广为被使用的全向性天线。The most common example of this type of antenna is the whip antenna used on vehicles, and the ground plane antenna that is usually mounted on masts or other structures。那么这种天线最常见的一种范例呢，就是汽车上的边状天线，以及呢这个地面上的天线，通常是安装在一个轨杆上面，或者呢是其他的结构上面。那这个 mast 这个字呢，中文意思是轨杆的意思。OK， 轨杆呢是这两个字。OK， 轨杆这两个字。The expedient vertical quarter wave whip antenna, like the antenna shown in Figure 9, is a single bare or insulated wire held vertically by a means of support and connected to the antenna connector on the face of the radio。那么这个克难式的垂直1/4波的边状天线呢，就像图9所秀的天线，它是一个单一的裸露的电线，或者是绝缘的电线。那么是连接在这个无线电的天线连接器上，然后呢使用一种垂直的方式来支撑住的。Okay, let us look at Figure 9。好，现在呢，让我们看到这个图9。Okay, this is Figure 9 vertical quarter wave whip antennas。好，这个就是图9显示了垂直的1/4波的边状天线 ，OK， like this or like this 像是这样，或者像是这样。 Okay, then what is an omnidirectional antenna? 那什么是一个全向性天线呢？ Okay, omnidirectional antenna. Okay, it is 25 minutes. 好，现在呢已经到25分钟了。Let us take a break. 让我们呢休息一下。